All right, let's just dive right in. If you're building anything on the cloud these days, chances are you're using AWS. But wow, there are hundreds of services. It's a whole universe of choices. So today, we're going to cut right through all that noise. We're going to focus on the one thing that really matters, the trade-offs. I mean, seriously, have you ever just stared at that list? EC2, EKS, S3, RDS. It's a total alphabet soup. And if you've ever felt completely overwhelmed by it, trust me, you are not alone. It feels like you need to be a walking encyclopedia just to know what everything does. But here's the secret. You don't. You really don't need to memorize every single service. The real skill, the thing that separates the pros, is understanding the fundamental trade-offs. So think of this explainer as your new mental model, a way to make smart architectural choices by figuring out what you're willing to give up to get exactly what you want. Okay, so let's start at the beginning. The most basic question you've got to ask, where is my code actually going to run? And right away, you're in a balancing act. It's this constant push and pull between how much control you want to have versus how much convenience you really need. So you can think of your compute choice like picking how you're going to travel. On one end of the spectrum, you've got AWS Lambda. That's pure convenience, right? It's like calling a rideshare. You just tell it where to go, and the car just appears. Then in the middle, you have something like ECS with Fargate. That's kind of like leasing a car. You get to drive your own apps, your containers, but you don't have to worry about the oil changes or the engine maintenance. And then, way over on the other end, there's EKS. That's where they hand you the keys to a full-on race car. You get all the power and portability of Kubernetes, but yeah, you're the one who's got to keep it perfectly tuned. So let's really zoom in on that core trade-off right there. On one side, you have EC2. That's your own virtual machine. You get full control, all the way down to the operating system. It's perfect for those big, persistent applications that are always running. And then on the total opposite side, you've got Lambda. It's built for these short, little event-driven tasks. You basically get to pretend servers don't even exist and just focus purely on your code. All right, so your code has a home, but what about all its data? And that brings us to the next huge decision, where the fundamental choice is between having this really rigid, predictable structure and having the ability to scale to, well, almost infinite size. Okay, let's break down storage. You can think of S3 as this gigantic, bottomless warehouse for objects. You know, your images, your videos, backups, all that stuff. Then there's EBS. That's like a super high-speed hard drive that you basically bolt onto your EC2 server. It's perfect for running the server's OS or a database. And EFS? Imagine your office's shared network drive, where a bunch of different computers, or in this case, EC2 instances, can all get in there and work on the same files at the same time. And for databases, the choice is just as critical. You've got your relational databases, like RDS and Aurora. These are your go-to when your data is super structured and you need things to be totally consistent and run complex queries. But then you have DynamoDB. It's a NoSQL database, and it is built for one thing and one thing only: mind-blowing speed and scale. We're talking single-digit millisecond responses. It's perfect for stuff like real-time ad bidding or the leaderboards for a massive online game. You know, here's a great example of a trade-off that you don't always have to make. Aurora is totally compatible with MySQL and PostgreSQL, which tons of apps already use. But AWS basically rebuilt its engine just for the cloud. So you get the familiar, structured database you know, but with the kind of crazy performance and resilience you'd expect from an enterprise system. It really is the best of both worlds. Okay, we've got our compute engine, we've got our data fuel tank. Now how do we hook it all up and actually open for business? That's networking. And it's all about balancing security, keeping things isolated, with access for your users. Let's just follow a request from a user and see how this works. Okay, so first the request hits CloudFront. That's AWS's global delivery network, and it serves up your content from a location that's physically close to your user, which makes it super fast. Then, from there, an application load balancer takes over and intelligently figures out where to send that traffic. And only then does the request finally reach your application, which is safely tucked away in a private subnet, totally shielded from the direct, open internet. Now, picking the right load balancer here is so important. An application load balancer, or ALB, works at layer 7. You can think of it like a really smart office receptionist. It doesn't just look at the building address on an envelope, it reads the person's name and department to make sure the letter gets to the exact right desk. It understands HTTP, which is perfect for microservices. A network load balancer, on the other hand, is like a lightning-fast mail sorter that works at layer 4. It only looks at the raw TCP address, the building, and just flings it in the right direction with the lowest possible delay. This is what you want for high-performance gaming or real-time financial data. Okay, now for two topics that absolutely cannot be an afterthought: security and cost. The best architects don't just tack these on at the end. They design for them from the very beginning, because the choices you make here are going to impact every single other part of your system. Let's make sure we're clear on two key security services. AWS WAF, that's your bodyguard at the front door. It's a web application firewall that stops common attacks like SQL injection before they can even ring the doorbell. Guard duty is totally different. It's like having a full-blown security camera system inside your house. It's constantly looking for weird, suspicious activity, like, hey, why did that server suddenly start scanning the network? Or why is it talking to a known malicious computer? Now, on the cost side of things, how you choose to pay for your compute is a huge lever you can pull. On demand is like paying with a debit card, pay as you go, no strings attached. It's super flexible, but it's also the most expensive. Now, if you know your app's usage is pretty steady, you can commit to a 1 or 3 year reserved instance. That's like getting a bulk discount, and it can seriously slash your bill, sometimes by over 70%. And then there's the secret weapon for jobs that aren't time sensitive: spot instances. You're basically bidding on Amazon's spare compute power. The savings can be jaw-dropping, up to 90% off. The catch? You have to be cool with AWS taking that computer back with only a little bit of warning. All right, let's pull the camera back now and look at the big picture, the final blueprint. A truly great cloud architecture isn't about chasing the newest, flashiest service. No, it's about deliberately and skillfully balancing all of these competing goals we've been talking about. And this is really where it all comes together. See, every single decision is a negotiation. If your number one priority is to keep costs super low, you're going to lean heavily on things like Lambda and spot instances. The trade-off? You're giving up some control. If you need screaming fast top-tier performance, you'll invest in things like Aurora and provisioned storage, but you know it's going to be more expensive and harder to manage. Chasing that low latency for users all over the world? That means using CloudFront and other edge services. Want to build something that's practically bulletproof? That means designing for resilience across multiple availability zones or even regions, but that's going to cost more and add complexity. Every goal has a path, and every path has a price. So you see, in the end, there's no such thing as a single best architecture. There's only the architecture that's best for your project, for your goals. It all comes down to a series of smart, informed trade-offs. And now you have the mental blueprint to weigh those choices and design with real purpose. So the only question left is, now that you know the trade-offs, what are you going to build?